In by parts, there are two parts to the integral. The first part is called u and the second part is called dv. Now, while choosing these two parts, you need to realize that dv should be something easy to integrate. If you look at the equation, you can see that secant x and tangent x is a derivative of secant x. So, this part should be your dv and x should be your u. Then you write it down. And then you take the derivative of u, which is dx in this case, and then you integrate dv, which is secant x in this case. Then the equation is as follows. uv, which is this part, from between the boundaries, and then minus the integral within the same boundaries, and then du times v. So if you apply this to our equation, we would get secant x times an x in the boundaries 0 to pi over 4 minus the integral from 0 to pi over 4 secant x times a dx. So then you work this out. Secant x times x stays the same minus the integral of secant x, which is equal to ln in the absolute value secant x plus tangent x. And then in the boundaries 0 to pi over 4. And then if you put the numbers inside, you get the answer to be root 2 pi over 4 minus ln root 2 plus 1. This method is called trig substitution. In trig substitution method, you draw a right triangle relating these two functions. So in this case, if we drew something like this, 1x and root x squared minus 1. If you drew something like this, we could easily say that if this was theta, we could easily say that now root x squared minus 1 is equal to tangent theta. And x squared is equal to secant theta squared. So, if we continue with this kind of integration, we have to also convert dx into dt. So, x is equal to secant theta. So dx is equal to secant theta tangent theta d theta. So instead of dx, we need to write this equation. So times secant theta times tangent theta times d theta. So this is what we're supposed to solve. And if we move forward with this equation, we can see that these cancel out and we get tangent squared theta over secant theta d theta, which is equal to, if you do the trigonometry, which is equal to sine squared theta over cosine theta d theta. So then we can write sine squared as 1 over cosine squared theta over cosine theta. Then we could separate these two and we could write 1 over cosine theta minus cosine theta d theta, and that would give us secant theta minus cosine theta d theta, which is equal to ln secant theta plus tangent theta minus sine theta between the boundaries root 2 to 1. Do not forget about the boundaries we had in the first place. They never change. So now we need to convert this back into x's. And if we do that, we get ln x plus root x squared minus 1 for secant theta minus cosine theta, and the minus root x squared minus 1 over x. So our boundaries for minus sine theta, our boundaries are the same from 1 to root 2. So if you substitute these numbers, you would get ln root 2 plus 1 minus root 2 over 2 as your answer. In the partial fractions method, we should first look at the factors of the denominator. X squared plus 4x plus 4 could be written as x plus 2 squared. So now this is a special case, because if we want to separate it as a over x plus 2 plus b over x plus 2, this wouldn't get us what we want as a denominator. So we have to make one of them x plus 2 squared, so that when we add these two together, we'll get the denominator the same. So then this is equal to 4x plus 3 over x plus 2 squared, as it says in the question. So a times x plus 2 plus ab gives us 4x plus 3 in this situation. It's simple adding. So if you do the math, you get a to be 4 and b to be negative 5. So then we write our equation as the integral of 4 over x minus 2 minus 5 over x minus 2 squared dx, which is now equal to this part, 4 ln x plus 2 plus 5 x plus 2 to negative 1 plus SE. This is how you solve with the partial fractions method.